It's a promising way to kick off the stream. Oh, it's all broken.
It's all broken.
All right. Hey, we're live now. So I guess this is going to be a debug stream. Hey, everybody. I'm Cody. I'm the head of developer support at Betty, and this is part of the AI for All hackathon. So, and Lisa, you want to give a quick introduction?
Hey, y'all. Yeah, I'm Lisa, also known as Nifty. I run Base 58, which is a Bitcoin protocol school, and I'm a part-time, I guess these days, Core Lightning contributor.
Cool. Yeah. And so Lisa and I were working on this a couple weeks ago of trying to wrap Flask applications with Lightning payments, just because a lot of the AI development is done in Python. And so just taking existing AI applications or AI endpoints, right, where it's like, hey, hit me, I go kick off an agent, or hit me, I go kick off something with LangChain or whatever. And how do we super simply wrap that with a Lightning payment, right? And so over the past couple of days, we've been doing some workshops on like L402s and how to do sort of like more of the lower level stuff. This is a working library that's already that Nifty published as part of like it's on pip now, right?
Yeah, it's on pip, but I'm thinking, seems like there's I think there's a problem with it. I gotta fix. I'm gonna fix it.
That's okay.
Fix it live. That'd be great.
Yeah, we can debug and fix it live. But so this is gonna be like a cool way that you can just like import this, and then it just handles a lot of the L402s for you. And so we can go over how it does that on the back end. But at the end of this, we should just have like a function decorator that you can add to a Flask endpoint, and have it work.
It should work great. I think the biggest problem is like I don't know what I'm doing on Python, but that's fine. It's like, do I know Python? No, not really. I mean, kind of. Right, we're selling it here. I think I might have fixed it. I don't know.
Okay. You want to share your screen? And we can
do that.
Jump in.
And hello, where do I share my screen? That one. Share the screen. Oh, this is great. Okay, I'll just share my whole screen. Yo. Great. All right, let's look at my Ellen Charger thing. So this is like, let's get a working example. I was just going to import from Charger, whatever, but I'm having trouble with that. So let's just use the local version, and I will go fix that one here in a second. Should work fine. I don't know why. Like, is there a way to turn this like Ghostwriter off? It's great sometimes.
I think you can do it in settings, but let's keep it on for right now. I'm just.
Sounds good. All right, cool. Yeah. So the whole idea is you basically. Let me look at my little like app really fast. Okay, so I've got in here a couple of like really small things. I've got two routes in here. One is just at the main, so when you go to index, this is what's getting hit. And it's returning an error, like it needs payment. It tells me I need 100 sats, and then it gives me an invoice to pay. You can also go to this other endpoint, which is cheaper. I don't know if I can actually type in this. The edit button? No, just kidding. I don't know how to edit that. That's fine.
Yeah, you can just hit it with a curl.
I'll just hit it with curl. Okay. So I can also hit another. Let me like move this over here then, so you can see both of them.
If you drop it next to where it says web view, like in that same bar.
Okay. Cool. So the general idea is when you use, so if you're unfamiliar with how web endpoints work, you can call localhost to hit them. So with curl, normally you wouldn't be able to see the data come back. So you'd want to say v for verbose. So you'd want to tell curl to be verbose. Because the interesting thing that's happening here, in my opinion, is like the L402 header part. And that shows up here. So when you try and call this endpoint the first time, I didn't give it any particular special authentication information. So what it tells me is like, hey, you need to authenticate with an L402. Here's a token that you can use. You note that there is no token. The reason for that is that this particular endpoint, and we'll get into tokens next week, runes. The particular reason we don't have a token, but we can, it does give us an invoice. So we need to pay this invoice and be able to hit this endpoint. So I've copied it now. I think I can pay it with this guy. L1. I have a Lightning kind of network set up locally. I'm going to try to pay it. It successfully pays the invoice. So once I've successfully paid the invoice, I need this little piece of data called the payment pre-image. This is basically proof of payment. So now I can make the same localhost call that I made originally. I can add in this pre-image, so it's new data. It's like authorization. Authorization is the name of it. I say I'm giving an L402 thing back. I would put my token here. This would be where the token goes, but I don't have one, so I'm going to leave it blank. Actually, I think we can do this. Will this work? This is going to blow up on me. No, the whole thing is completely broken. Okay.
No, you've got double quotes wrapping.
The problem is that I'm trying to call something that doesn't exist. Charger has no attribute, verify pre-image is the problem. So like there's a problem in my like app thing. This verify pre-image thing, it's like this doesn't exist. Here, so it's breaking is a problem. I updated this, but I'm not sure that my main.py got updated. Let me go back to it. From sale and charge, import subs, manager, sell and charge. So it should be importing this. Sorry, we're gonna debug this for like half a second. I just do like, oh, so it should be printing the rune and the pre-image when it hits here. Yeah, it's got the rune and the pre-image. As it prints that out. Move this over here. This is like, oh, I see. Yeah, the rune is token. That's right. It's not able to find this video. Oh, I know why I'm TK. Okay, problem solved. It's time for real. Unfortunately, okay. Problem is I was calling the wrong method thing. I don't think I even needed to do all the stuff that I did. It's fine. So I can try it. It's gonna fail it and say that I need payment. I'm gonna pay this one more time. So one more time I'll do the thing. And then now whenever I call authorization, you should be able to just pass in this pre-image token that you got. And the token is the pre-image. The pre-image is only something that you get after you've paid the invoice. So it's like proof. Yeah, it's proof of payment. And so there it worked that time. It says this cost you 100 sats. So if you try and call it again, like a second time, it's going to fail and it's going to give you another invoice to pay. So this is why it's called, like, this particular demo is called pay-per-view, because you basically are allowed to, you pay an invoice and then it lets you, what do you call it? Hit that same endpoint one more time with a valid payment token. And then you can, what do you call it? You hit it once with a valid payment token and then you get a new invoice that you have to pay. But that's kind of like, that's not super useful, right? Okay, so Cody, what should we talk about? This is like, all right, so it's really easy to add in. Basically, you have to have, the small downside is you have to have your Python server running on the same machine as your Lightning node, so it's able to talk to it. Hopefully by next week, we'll have it set up so that you can have a remote Lightning node that you're connecting to. But for right now, you just have to run the web app on the same place that your Lightning node is. Shouldn't be that hard. Cool. And then the nice thing about it is you can change. So different endpoints can cost different amounts. You can just pass in, like, I want this one to cost 500 sats, or maybe I've got a really expensive endpoint. So this will let you price your expensive endpoint. Return really expensive endpoint. So as it's written right now, it'll let you charge, like, I don't know, let's charge 5,000 sats to hit this endpoint. So if I stop it and restart the app, now I should have a new endpoint called, oh no, I didn't rename it. I should call it expensive. Okay, one more time. Stop and restart it. So now I've got a route called expensive, which I can hit with curl. So I hit v localhost. It's on port 81. Let's call the expensive one. It says I have to pay this invoice. One thing that might be nice to know when you're trying to pay an invoice, it tells me it's going to cost me 5,000 sats. One thing that might be nice to know when you're trying to get this thing working, you can always use decode. So if you get an invoice back, they could be like lying to you about how much it costs. So it's always a good idea to verify how much the invoice you got is asking for before you pay it, just in general. It's cool. It tells us that we're getting the expensive. This is like for getting the expensive endpoint. And it tells us that the amount is 50,000 sats in MSATs. So this looks good. So that's okay. I'm like, okay, I'm going to pay it. Pay invoice. No. Invoice. Boom. Now that it's paid, you can hit the same thing again with the same header in there. That's authorization. L402. You can put whatever you want in the token, and then this. And that works. So I just got a response back that's like, hey, really expensive endpoint. If you try it again, it won't work. It gives you a new invoice to pay. Cool. Okay, so that's how you can use the existing API to charge different amounts for different endpoints that you rate using Flask, which is pretty cool. I've got to fix that bug in the published package, but I'll have that fixed by like actually this. Okay, so that should be fixed. Token. Cool. Cody, is there anything else that you think we could do while we're?
Yeah, I think two things. So for there, you're actually taking the request and then you're putting it into the description, right? Is that the way that you're linking that? Because so this is like something that we covered of like the reason why we were passing the token as part of the L402 is because the token has a commitment to the original request that you were doing. But what you're doing is instead of putting in the token, you're putting it into the description, right?
That's right. Yeah. Oh, this is a good point. So if I pay an endpoint and then, oh, you're right. I don't link these to, oh, you're right. I could get a cheap one. I think you're right. I have a.
Yeah. So let's do this because I think this is like an educational experience of like why we have the L402 protocol, right? Is that so?
Tokens.
Yeah. So we could try to do that, and then I think afterward, maybe let's try to hack in. Like if we don't want to use runes, we could use the PyMac library because that's pretty simple for it. But because the issue, and this is like something for like when you're doing AI chatbots for this, is that they hit you originally, you get the invoice for like a 2-sentence prompt, and then they swap out and they say, okay, hey, I'm going to change the body out of this, and I'm going to send you like 20,000 tokens that I want you to put in part of this chat. And the invoice that I paid was only for the original request, which was only the 2 sentences, right?
Yeah, and so you're right. There's a hole here. I called the cheaper one, right? But now I can call the expensive one, right? With the same. Yeah, I think you're right.
Yeah, and so that works, I think, if I mean, if you just want to, well, no, I think, yeah, so I think that'd be a good one. If you want to, we could do that. We could try to patch this hole, and then
yeah, sounds good.
Cool. Yeah, so I think there's two ways. I think there's two ways you could do it, right? So I think one of them could be because this was my original idea for L402s was I was like, hey, why do you need that? Couldn't you take a hash of the body of the original request and the endpoint or whatever, and you could test it that way? But it's like that's actually not that good because you want to be able to give them a token and then have the server side just treat it like a normal session token, right? Where it could have like server side logic of you can use this 15 times or you can use this 100 times or you could use this for 3 days or something like that, right? But
yeah, that's right.
Yeah, and so the PyMac library works pretty well for that. Do you want to try doing runes for this?
Sure.
Or
yeah, we can try it. I haven't looked at the rune stuff in a bit. But...
Yeah. So for anyone who's wondering, so as part of the current PR for the L402 specification, and we're going to have like a spec meeting for L402 specification discussions next week, is that it requires a macaroon, and a macaroon is a specific type of cookie and token, right? And so the discussion now is, hey, we should make this generic and just have it be a token, because the token, you can use a macrune, you can use a JWT, you can use a rune, right? And Lisa can explain how runes work after this, is that that's just server side logic, right? Of that the server side is choosing.
Right. And
yeah.
I'm sorry, go ahead. Yeah.
No, you're good.
Yeah. So basically you want, like Cody was saying, you want a way to scope each of these like pre-images basically. So this is a really dumb server, kind of just assumes there's like one price for everything, right? You can hit any of whatever. What you really want to do is on this verify pre-image thing, you also want to pass in like the token, right? Actually, there might be more info. Really, you just want the token though, right? So what you want to know is that
the way that, so the 402 specification says that you need to, in the token, it has to have a commitment to the payment hash, right? And so if you pass the pre-image and the payment hash inside the token, then you should be able to hash the pre-image and get the payment hash inside the token, right? So that's like one way to do it. But that's also, this was something that Callie pointed out a couple of days ago, right? Is that that's actually not committing to a specific, well, that's committing to a specific invoice, but there could be other things that changed about it. And so the other thing you might want to do in that token is commit to like a specific request body, for example, right? But so using runes, you could do that, of adding additional caveats that way.
Yep, totally. So I think some design goals of how we're gonna like make this better, right? One of the problems is it needs to commit to payload, maybe. Potentially. This is kind of like for the case that you were talking about with the this is terrible. Kind of how you're talking about, you can call the same API call, but depending on like the data or the amount of tokens that you have in it, changes the pricing, right?
Yeah.
So what else do we need to do?
Yeah, the payload of the API call, and then the specific invoice, right? So it's not that like you pass back an invoice, they pay that invoice, and they hot swap the rest of it, right? So you need to do the preempt. So, and the way that 402 L402 spec recommends it is that you just put the payment hash inside of the token instead of the full invoice. But like, you're a good person to answer this. Is why would you just want to do the payment hash instead of the full invoice?
Instead of the full invoice?
Yeah, because wouldn't there be stuff in the invoice that you would want it also to commit to besides just the payment hash?
Yeah, ideally your Lightning node only ever issues one invoice per payment hash, if that makes sense.
Okay.
So gotcha. If you've generated a payment hash in association with like an API call, in theory, whatever like data you put into that invoice will be like, you can find and reference by that like payment hash. Your node should never reissue like the same payment hash for different things, because that would be a big problem.
That makes sense.
Especially because they're supposed to be like proof of payment of a specific invoice. So if you had the same payment hash for different invoices, like it is a unique identifier for an invoice, or like a bill of materials, so to speak, that you're looking to pay. Okay. So what we really need is we want to commit to the payload of the API call. We need to commit to the invoice payment hash. And then maybe we commit to the endpoint, like the request, right?
Yeah.
This is all great stuff that I'm gonna have to learn how to do this with runes.
So I think we could figure it out with runes. Like the Pi Macaroons one is pretty straightforward for it, or we could do it. But so I think that would be maybe a good starter point for it. Then we could swap out with runes eventually. But for the Pi Macaroons one, I have like a example that I can send along with working code for that. But so for here, or you want to just try doing it with runes? I think it would be.
Yeah, I think it's fine. I mean, we can always start without using runes and then see, like, we'd like start from scratch. Like, okay, let's design something naive, right? Because like runes and macaroons are only really useful if you want to extend it, right? Or add extra additional caveats. So I think that the original naive design typically has to be like, let's make an HMAC, right?
Yeah.
Cody, can you explain what an HMAC is?
An HMAC is just a way to like cryptographically like take a bunch of information and you just create this thing where you basically create a signature. You're like hashing it, creating a signature over it. And it's like hash message addressable content, right? Like that's what HMAC stands for, I think, right? Is that you're just taking this thing and then you pass it along. You say, hey, this is like a cryptographic commitment to the stuff that I committed to. And so if you can provide that original stuff and the HMAC, then it's like, yes, this is the same thing that you authorized previously.
Yeah, that makes sense. And one of the things that you need to make a good HMAC secure basically is requires a secret on the server side, right?
Yeah.
So the way that it works is you're going to define data that you want to commit to, and then we're going to have to mix in a secret that only the server knows. The server knows in order to just stop that. Mix in a secret that only the server knows, so that basically that makes it such that no one else can recreate hashes of data that you didn't create, if that makes sense. Yeah, okay. So it's like making an HMAC, I think. So we need a few things, like we need a few things to make this work. First thing we need is we're gonna need an HMAC routine. We're gonna need a secret data, which I can just like make something up for our purposes, and then we're also going to need a or like a source of secretness. Spell it right? I don't get it. Okay. And then you're also going to need basically a schema of data for the data we're committing to. Okay, so what does that mean? Basically that means like, okay, when a web request comes in, web request arrives, what data in the request are we committed to, right? So I think like two of the obvious things that Cody noticed I was putting in the invoice were the method, right? Which is like get, put, post. This is really annoying. What else? The path. So like sure API v1 charge, right? And then the other thing that we might consider adding do like a timestamp, other headers, if we wanted to add other headers, maybe like a session cookie, the body of JSON, right? Okay. So let's just, for this one, let's just do the method, the path, and then whatever is in the body of the command, right? So basically this means that if you send up a body with some JSON in it, you'll have to exactly replicate the call in order for the payment that you wanted to make to be valid, right? Cool. Okay. Any questions on that so far? Does that make sense, Cody?
Yeah, it makes sense.
Okay, cool. I can hit this editor. It's fine. So we're gonna want I could just pass in the request here, but I'm lazy. I'm just gonna do method, path, data, and then I'm gonna have the secret be initialized onto the self thing. What's it doing? Why is it doing that? Oh, and we also want to include the pre-image or the payment hash, right? Okay. These are all things we can do. Mage HMAC. I just need an HMAC routine. Is this one? Is this a good one? Is this one I'm going to use? I don't know how to. This is really annoying, man. Let's go find HMAC routine. Lib HMAC. I think I could just import HMAC. I just need like an HMAC example. Why are these like? This is really bad for examples. Python HMAC example. Okay. What does MI stand for? MI is what you want. So that's like the embedded data that they're committing to. Here's the key.
So what they're doing there is they're just taking the whole requests, right? So that's like the endpoint and the body
This is
parameters
actually, so what
afterward.
you're seeing, this MI thing here is, so this one, the data is in the URL.
Yeah.
You can have requests where the data is like in a JSON body, so it's
Yeah.
like separate. But this would work great if you've got like query parameters. Like it kind of just depends how people are getting data to your server. If they're
Hmm.
sending it to you like this way, then you just use like the whole URL basically.
Yep.
I'm assuming they're gonna send it to us as a JSON package, but as like a JSON thing, data thing.
Yep.
This seems easy enough. Okay. So you gotta mix in all the other answers to get this. What is this? Why is this annoying? All right. Perpetually annoyed. It's fine. So I'm gonna add our like secret. I don't know. Cool. We just need to import HMAC, right? Import HMAC. Done. Wow, it's so easy. Does this count as rolling around in crypto? I don't know. Mag equals HMAG, new, self-set, secret, sure, digest mod 256, that seems fine. Okay, and then what you're gonna do is, I actually think I wanna do like dot encode on this. Can I go to my console if I have some like, if I have some data, so if I say like info equals is the secret string, I do encode, what does that give me? Yeah, that works. Okay. We pass in the secret, we pass in, let it know we want this digest mod. Now, what we're going to do is we're going to have like our list of data that we want to add. So we're just going to update this HMAC with all the data that we want to add to it. Oh, I'm missing one, which was like the payment hash. What have we got in here? HMAC message. I think you can just call update repeatedly. This is annoying. It's fine. So what else? Mix in the payment hash, encode. I don't know if this is like bytes or whatever. There's 2 bytes to hex, max that update. Encode. Update. So basically we're like adding in all the stuff, right? Path. And then whatever the data is. It's a little bit making a smoothie. You just add all the ingredients in and then send back the hex digest of all of it. And that should give you a nice Mac that commits to all this data. Cool. I feel like I should test this, but test and prod, it's fine. Okay. So we've got this make HMAC thing. It's like an internal function. Okay, so now I just need to call it, right? So now I need to get the data to send it. For now, I should be able to get all this stuff out. So, okay. So now we're going to have an HMAC that's on there, which is, I'm calling it a rune here, but it's like, we'll call it an HMAC. I think I need to make this a little easier to see. This is like really kind of a nasty thing because of the way the decorator stuff works. It's like this leveled down so that you're able to either call charge without an amount or with an amount, basically. So there's a default amount. Anyways, that's why this looks like this with all this callable stuff. But the general idea is that we're going to get this HMAC out. We're going to send it in. We're going to get the HMAC out. We're going to verify that the pre-image, instead of verifying the pre-image now, what we're going to do, well, we're going to verify the pre-image, but we're also going to, let's change this to verify HMAC. So I'll pass in the HMAC now, basically the token and the pre-image. And instead of having to save, I used to save a list of valid pre-images. The cool thing is I don't really need to save any state anymore. So it's stateless. So I can get rid of this whole invoice hash list that I had. Because now, since we're committing to the data, it's kind of cool. by committing to the data in the HMAC, you're basically putting the state commitment into the HMAC, which means that you don't have to save the state because you can, the HMAC is kind of like this carrier of what the state was, and you can recreate the commitment to that state using whatever data the caller sends to you.
And that's the great thing about the L402 is because the L402, the server can be stateless for it. And so all of the commitments are inside of the HMAC. And then when you provide the pre-image, that's the proof. That's the only thing that you need. And then the server can respond to it.
Exactly. Yeah. So that's cool. So I used to have, so it's like the original example of this had this little list of pre-images and it could grow unbounded, right? If you have state, all of a sudden you have to have a strategy for managing state. But with this HMAC approach, we can remove that whole state thing. Now, whenever we get a HMAC and a pre-image in, first thing we're going to do is we're going to recalculate what the pre-image hash is. Because once you have the pre-image, you can just pass it to SHA-256 and find out the pre-image hash. Now, instead of iterating through my list of pre-image hashes and deleting it out once it gets paid, that's that. Now we're going to recreate. I also need to pass in the data I need to recreate this. So I'm going to need the method, the path, and the data rate. It's like, now I just need to recreate the, this would be the expected HMAC is going to be equal to, that's right, control time. Cool. So basically we'll call make HMAC using the pre-image, the hash that we calculated, the method, the path, and the data of the current request. And then all we have to do is return whether the expected HMAC equals the provided HMAC, right? This is the one that they sent. Cool. And it's really, should be that simple. TM. As long as I've like provided the right format of data for all of this, we'll be fine. Okay. Cool. So now all I need to do is update two things. This is no longer called verify preimage. It's now called verify HMAC. And instead of having a preimage, I need to also pass it the HMAC, the preimage, the method, the path, the data, HMAC, that we get back, the preimage, the method. Where do I get the method from? Request.method. I could just pass the request object here, but I'm being kind of lazy. The path needs to be the same. And then I need to get the data out. I'm just going to pass in an empty string for the data right now because I'm lazy. It's fine. And then we also need this on the other side whenever we create a L402, right? So whenever we do this L402 authenticate, right now my token object is empty. I just need to add the HMAC here. So I pass it back in this token object. And I need to calculate it. So I need to calculate the HMAC. It's going to be the same, I think, here, method, path, and we pass in the invoice hash, the payment hash from the invoice. So yeah, I think that works. Okay, cool. Any questions so far? That seems pretty good. Let's see if it runs. How bad did I do? Decent. Oh, I think there's still an invoice hashes account. There is no invoice hashes. Okay, I'm gonna delete all this stuff out. Oh no, I can leave it. We have a secret. Somewhere I'm calling something that doesn't exist anymore. Invoice hashes. Oh, okay. I no longer need to save this. Basically, I was trying to save the invoice hash, but I don't need to anymore. Okay, does that work now? Stop, run. No, we still got another. And HMAC is missing a positional argument on line. Looks like line 84 here. Call make a match between the payment hash, method, path, data. This is right. Let's look at this a little closer. Self make HMAC payment hash bracket plus invoice path. Make HMAC is requesting a positional argument called data. called verify.
I think you're not passing. So when you're creating, wait, yeah, because you don't need to pass the HMAC there.
I'm gonna be make HMAC as a self. There's this self thing. It's you know, someone who knows Python better than me. Okay, now it's working fine. As it has to do with this weird thing I'm doing with class methods and the self thing. Like it's ugly. Don't copy. Don't follow my lead on this one. This is not good. Cool. Okay, so it's doing what it's supposed to do. So if we go look at the web view, it should be giving us like an endpoint now. Let's go like do the curl thing. Curl v localhost 81. So just like the normal one, and that should give us back a payment invoice. Oh, so this time it gives us back two things, right? It gives us back a token and an invoice. So now I just need to pay this guy. Okay, so now I get my payment pre-image. So this time, whenever I call the same curl back, instead of just passing in something random, so I'm going to get rid of this expensive thing. I want to make sure I'm calling the same thing. Instead of saying, well, hang on, first I'm going to replace out the payment pre-image that I got back. I need to send that back. And then I also need to change, I have this little, I don't know if you noticed, it says hi here. That's where the token goes. I don't really need the token. The token I need is this one. So in the authentication, it sends me the token. I just need to copy it and put it here. And then hopefully this works. We didn't test it. So, hey, that works. It's great. It worked great. If I call it again, I think it'll work again. So this is, oh, okay. So this is one of the things I think that this is maybe where like the rune stuff starts coming interesting and comes into play. The problem with just having an HMAC is there's no timeline on it.
Yep.
So we can talk about how to do that. Like, yeah, I think maybe that's the next thing we can do is like add a time buffer to it. Or we'd have to keep track of which HMACs have already been used, whatever. So
yeah, or you could put, yeah, I was thinking you could put like a timestamp inside the body or something, right?
Yeah, you can add a timestamp component to it. And if it's within, you have to pay it and have it paid and then use it within a certain time. Then you start, I feel like when you start adding time stuff, you start getting into user experience questions, right? Does Rune fix this? Maybe Runes fixes this. Yeah,
but the simplest way is just after, so because this is stateless, right, is that somebody could show up the same time and use the same invoice and pre-image with the same request over and over and over again, right? And so you'd want to track that, hey, this payment this payment hash has already been used or something like that.
Yeah, but the cool thing is, just to like kind of show you how we've bound it to the right endpoint, right? I tried to call the expensive one using the working stuff, and it's like, no, you need another token and you need another invoice, right? Yeah, so what were the ideas, Cody, we had about like, so now we have a new problem, right? So we've kind of done this. We have a new problem, which is new problems are fun. So new problem with the stateless thing is you don't know, there's no like there's no limit on how many on repeatability, right? So there's a few things we could do, right? We could go back to the tracker thing only. Yeah, how do you only allow a token to be used once?
Yeah, so there's a couple places we could put this, right? So like Core Lightning itself has like a SQL database that it's using. And so we could probably have the node track it. Or
but that's not really a separation of concerns, right? Core Lightning is only supposed to be like your payment guy, right? It just lets you know. The pre-image stuff really just lets you know, like, hey, it's been paid. So you could keep data there, but like, you probably want to just keep the data local to your web app.
Yeah. So we could store it in a separate database running alongside this server, right? Yep. That's like another way we could do it, of just like a list. We could just have like a key value store of that. Here's the payment hash and tag whether or not it's been paid. right? Or we could just be super dirty and write it to a file.
Yeah, that seems fine. Other thing that you could do is you could add a timeout to the token. So that wouldn't give you a number of uses, though. That would be
well, yeah, you could do a timestamp for when you created the HMAC and then pass that back, and then well, you'd have to pass the timestamp back as well, because like you'd have to store the timestamp at some point.
You can send the timestamp back to them as so then basically I think what you get is like, I think what we're getting at is like, it's very hard not to have state, right?
Yeah.
We like moved away from it and then we found a new problem. So you can do stateless stuff, but the problem with that is that they become like infinitely usable.
Yep.
Once they're like ungated. You can add a timeout to the token. You can do this. We could like do this using a header, but that would mean they're allowed to make as many calls as they want up until the time elapses to some extent, right?
Mm-hmm.
Unless you have something where you're counting how many times they're using it in a time period, which I kind of think you need for runes. I think when you add runes, you're going to need to add that anyway. Like, I think like the caveats on runes and the way they're implemented in Core Lightning, you kind of have to add all that state saving and like, you don't get away from the state problem, really. What you do get away from, and I think the important thing is we never had to go back. And so like, you don't really see it here, but there's only one time you need to call Core Lightning, and that's when you're creating an invoice. After the invoice is created, you never have to talk to Core Lightning ever again, right? And that's kind of the benefit of doing the HMAC commitment stuff. Yeah. Okay. So, right. So let's figure out a way maybe to like, which direction do we want to go with this? Maybe we just have something we write to a file. Let's just keep it in a JSON blob, yo.
Yeah.
Yeah. There's literally nothing wrong with this until you start needing to change what gets written to the JSON file, and then you have like, writing things to files is great until your schema changes, and then you realize why database schemas exist.
Yes, but for this one, it's just basically a key value store, right? Of that like tagging that this specific payment hash has been paid.
Yeah. So what kind of data do we want to store for this? Like, what do we want to save? I'm just gonna make like a JSON object, and we can just like save it to disk every time it updates. That'll be, anyways. What do we want to save? All we want to save is like the token, the HMAC token, right? And then details about it. What kind of details should we save about the HMAC token?
We could just save what we put in there, or
you won't need to though, because the method itself will carry all of that data for you. Maybe what we really want is like last used.
Yeah, that makes sense. Or we could just save it with, we could say, hey, this pre-image is valid up until this point. We could we could have a timeout for it.
Okay.
Right? So once we create the invoice.
Single use, or is it like timeout, or like if you pay, we could do like a single use. We could do like burn tokens. We could just make a burn token list.
Yeah.
That's it.
Yeah, I think we could do it that way, and then afterward we can do it, or we're probably gonna run up on time against that, but we could do for timeouts, right? So it's like, hey, you can use this 5 times within this time limit, right? That would kind of be like a for that one, you need a timeout. You need a timeout time, right? So we could do like that time plus 30 seconds or something.
Yeah.
And you could have the number of times it's been used.
Wait, let me just like restate, because I think I missed some of that. Like so you want like a can be used X times in like X seconds.
Yeah.
And then if you don't use it that many times in X seconds, it's burned.
Yep.
And if you use it X times before the time elapsed, it's burned. So there's like 2 burn conditions, kind of, right?
Yes.
There's burn conditions. Use X times, or X time elapsed. X seconds elapsed, right? Since requested?
Yeah, so when they originally do the request, you could do that as part of the HMAC, right? So we could put the timestamp in plus like 30 seconds or something, and then that gets stored. And then when you do the lookup against it, then they would have to pass along what the original timestamp was that they sent it.
Yeah, you do that. On the server side, you don't have to. Yeah, that's easy. The X6 and elapsed is easy without state.
Yeah.
It's without server state. It's the use X times that gets difficult, right?
Yeah.
So this X, okay, so let's add the X seconds elapsed thing really easily. So this will just be like, now we want like a, I don't know, Unix timestamp, right?
Yeah.
Which is just a number.
Yeah, would you put that inside of the HMAC, or would you just have it be when you store it server side?
Oh, you could do either. If we're trying to make it as stateless as possible, we can like literally just use this timestamp thing, and then
But then
it
the
adds a little bit more.
client would have to send the timestamp back.
It's more complicated for the server, and the way that they do it is they just have to like echo back a header, so you can add it as a header, like add the
Yeah.
activity as a header, and just have them echo it back in the response. But
Okay.
if your client is like dumb or whatever, or your client doesn't, let's say for whatever reason we don't want, like the nice thing about the current thing is that the only thing the client needs to change or add is this authentication stuff, right? Like the L402 stuff. And that's pretty straightforward, and like hopefully it will be standardized soon, TM. Let's say that we like for whatever reason want to just keep the seconds on the local side. So then I would just make like, I don't know, I'm just gonna make a like, what is the so bad at like burned tokens. So basically make a dictionary where you have like the HMAC, and then you have like a thing which is another dictionary, yeah, which is the count, and then the per seconds. Right? It's an option. If we do it this way, this means we have to keep track of every HMAC we make. The other option is well, if you want to remember the birth time of every HMAC without grinding, then yeah, we have to write down what time every HMAC is done. Otherwise, we have to get them to send the seconds back.
Yeah, I think so, because I think we're coming up on time in about 12 minutes. So I think let's do the time one. I think that's when we create the HMAC and record it server side. Then we'll do the time, and then as part of the check, we'll do time plus 10 seconds or something. And so they're paying to access the API for the next 10 seconds.
Yep, that sounds good. I'm not going to actually serialize this disk in 12 minutes probably, but I think we can easily get the data thing done and then leave like the how do we like serialize and unserialize this. I don't think that's a hard problem as a it's like as an open question. Okay, cool. So what we want to do is when we make an HMAC, after we make the HMAC here, we're going to insert it into insert made HMAC into burn list. So burn list and tokens has HMAC equals, I don't know, a new objecty thing. Maybe there's a more whatever. And then the birth time would be, I don't know how to get the current time in Python. Is it just now?
Daytime.datetime.now. So import daytime. Yeah. Sure.
Great. Okay, that's easy enough. Cool. Okay, so that'll add it into our burn list or whatever. I mean, this isn't actually a burn token list anymore. We'll just call this like delp tokens, whatever. This is the ones we've handed out, right? And then on verification, so now we have a verify HMAC thing. There's a couple things. So I'm gonna go ahead and just like, if this is not equal to this, then return false, right? Then we actually look up the HMAC. So first we check that the HMAC is valid at all, right? An early exit. Then we like look up the token info is equal to delt tokens, except instead of HMAC, we just put the HMAC in here, right? And then we would check what are our parameters here? Like if count greater than, if birth time, so time now equals datetime now. If token info birth time is less than now minus, I don't understand what this is. Time delta 5 seconds.
Time delta is for you can do like 5 seconds off from wherever you're passing it in, right? So that would be let me go check that up. There's documentation.
This is okay. If the birth time is less than now minus 30, right? So if it's less than 30 seconds old.
Yeah, if that there's an error, then there's like a time delta thing that you normally have to do, I think.
Oh, okay.
But
I can do that, yeah.
Yeah, but that's just if it throws an error.
If token info count is, I don't know, how many times should you be able to use it? Like 5 times in 30 seconds?
Yeah.
Otherwise, we need to update the token info. I need to set the, yeah, this one, and then return true, right? So we update the token count every time we return true. Every time we return.
Yes, so you'd have to go update back in delt tokens.
Right? Okay.
So delt tokens HMAC token info count, or sorry, HMAC count equal, or token info. There we go. There you go.
Okay. Man, what is this life without pointers? I don't know what you guys are doing here. Okay. Cool. Okay, so that should in theory work, question mark. I don't know, let's try it. Stop, run, go gadget. It's gonna hit it. Okay, so it didn't error out. It hasn't hit the verify stuff yet, but creating a token seemed to work. Okay. So let's just go hit our thing. We got like 5 minutes. Let's curl this guy. Curl 81. Authorization. Let's go. I just gotta pay this. I'm gonna run it. Hopefully I don't run it out. Okay, so I got this. So then I can just like curl the same thing again. I'm expecting this to work, right? As long as I get it done within 30 seconds. If I talk slowly, maybe we'll run out of time. L402. That's not
authorization.
Right. Oh, okay. That'll cause problems. Computers are so picky. They should just know what I meant. Okay, and then I need the token, which is up here somewhere. This guy, this token that I made. That seems good. Go. Oh, we got an internal error. That's fun. Okay. Something happened.
Yeah, that's the time delta. Right.
Time delta.
So unsupported for datetime.data. Yeah, it's like a time delta thing. We can just quickly, if you just look up datetime.datetime time delta or whatever, or Ghostwriter could probably do it for you. But it's that datetime.time delta or something.
Where does it go? It's been trying to like tell me what to write for ages now, and
yeah, just look up time delta Python. There's like a way to do this.
Oh, time delta. I just need like really quick example.
Yeah.
Time delta days equals whatever. Time delta seconds equals.
Yeah, so it's datetime.time delta, not datetime.time delta. Not, yeah, there you go.
Seconds equals 30. That should be functionally the same thing as what I had, right?
Yes.
Okay. Stop, run, shell. It should fail on me. Oops. Okay. Wrong this time. Delt tokens equals verify HMAC. What is it not like?
Key error. Oh, because it's looking out because it didn't make when you stopped and restarted it didn't save the
okay
invoice, so you have to hit it again at the beginning. So just hit it without the header and then.
Well, this is a bug we should fix, not in delt tokens. Okay, cool. Oh, actually, that makes a lot of sense. All right, let's try again. Now I should get a failure, not it. Okay, cool. So I should get a new thing to pay, right? Which is great. Let's do L1 pay this guy. And then I can run the same thing. I just need to delete out both this, which was the pre-image, and I have to also replace the token, right? Token commitment. This guy. It's here. Get the token out. Cool. Wait, it says needs payment. What happened? My authorization didn't pass. Did I take too long? I have taken too long. It doesn't tell me why, and I didn't print out any of the reasons.
Is it the now minus daytime time delta 30 seconds? Is that? Yeah, I think it might be an issue with it might be time delta minus now something. I don't know. I think it's an issue in the time delta.
I'll just skip this for now.
Yeah, could we just skip that and then just try to hit it 5 times and then.
Yeah.
Yeah.
That should work. Okay, stop, restart, go. Shouldn't fail if I try it. Should give me a new one, which I have to pay, right? And then all I have to do is are there clients that do all this for you? That would be sick.
Yes, there are. But it's cool to implement the whole thing.
With Scratch, yeah. Nice. Works.
Okay, so then hit it 5 more times.
4, 5. That was the last time. Now, yeah, it says
beautiful. All right.
Yeah.
So that works. And so that's that would be that you could wrap a Flask endpoint such that somebody can hit it 5 times if they pay you.
Yep, exactly. So there's a couple of things here, we've got 2 minutes before it's timeout. There's a couple of things I think to think about here. One is as a library, so this charger thing is a library, right? I need a way to basically you need a way for people to express these constraints, right?
Yep.
How do we say only 5 times, or how do we say only the last 30 seconds, right? So this library, as I've written it, is really tightly tied to these particular parameters, and it's hard to add new ones. Let's call those constraints. So I guess next week maybe we're gonna do one on runes, and we can talk about how we can use runes to help us solve these problems and be flexible.
Because runes, just like macaroons, have that flexible caveat system, right? Where you can basically configure whatever caveats you want into it. And so that'd be super cool. All right. That's good stuff. Awesome. Thanks, Nifty.
Great. Yeah, anytime. Sorry for the back and forth, whatever, but we got there. All right, cool. I gotta go ship a patch for that charger thing. And also we need to add runes to it because no one should use it till I have runes in. I think that's what I've decided. Okay.
Cool. Awesome. Thanks, Nifty.
Bye. See ya.